So hey everyone, I am Aditya and today I am solving a problem single number. The problem statement is that we are given with a non-empty array of integers nums. So a nums array is given to us which is having some integers and those particular elements are like every element is present twice in the array except that one element which is present only once. Okay, so that is what we have to find here, that single one, that single number which is present only once, which is appearing once in the array. One other statement given here, that we have to, whatever the solution we are implementing, that must be with a linear time complexity, and also it should use only constant extra space. It means the runtime complexity, linear runtime complexity, that should be big O of n, and for that the space complexity must be constant. It should not use any extra space, whatever the solution we are going to implement here. Now to have more clarity on this problem, check the examples. This is a particular array in which we can see that 2 is present 2 times and 1 is present only 1 time. So here the output will be 1. Here we can see that 1 is present 2 times, 2 is present 2 times, and 4 is present 1 time. Here the output will be 4. Now in the third example, the array size is 1, so only one element is present here. It means no need to check for any uniqueness because one element is there, so it will be the only element which is present as a single number. It is not present twice, obviously. Now for the constraints, here we can see that the nums array is a varying, its size is varying from 1 to, it can go from 1 to 10, 3 into 10 power 4, and whatever the values will be present in this nums array, that can be from minus 3 into 10 power 4 to 3 into 10 power 4. And this is a particular statement where it is saying that each and every in this particular, each element in the array will be appearing twice except that one element which appears only once. So here it is a kind of constraint that we will not come across a particular test case in which any particular element is not appearing once. So whatever the test cases we will be having in any input array, that will be kind of that whatever the elements are there, they will be present twice, and one element will be there which is present once. That's will be valid for every case. That will be a kind of mandatorily where we will have to find that single element which is present once. Okay, all right. Now let's talk about the approaches and that how we can solve this particular problem. Coming here, I have taken the example, and this is the example I have taken from the problem statement. This is example 2 we were talking about earlier. So here is the nums array which is of size 5 and having these elements. Here we can see that this 4 is appearing once in this nums array, 1 is appearing twice, and this 2 is also appearing twice here. Okay, now we can see, yes, this 4 is coming only once in this, so 4 will be the output. Now what are the approaches we can come across in order to solve this particular problem? So the simplest approach which I can think of to solve this problem is that I have to find a single element which is appearing once. So what if I can do that? I can go at every index, I will take that element and start checking in the whole array if it is present again. It means if its copy is present in the whole array. That I can do. I can simply go at 0th index, then at one, and then at first index, then at second index. For every element, I will do this particular repetition, that to check in the whole array if its copy is present or not. If its copy is present, it means it is twice. It is present twice. Otherwise, otherwise it is a single number whose duplicate, or it is present appears only. It is present only once. So that's what the approach is all about. Now let's get into this approach more deeper to understand more about it. So firstly, let me write here the solution 1 we are talking about, and in this solution 1, firstly let me take this input array. This is the input array we are having, and now what I am going to do here is, as I have just told, that I will go at every index and start checking in the whole array. If it is present, I will go to the next element. If it is not, then it is my answer. I will return it simply. So I will go at 0th index and I will take a variable just to traverse for the whole, or for all the indexes, to go at every index. And now when I am at one index, I will start traversing the whole array. So for that I will need another variable j. But the important note here is that we have to remember, whenever we are checking for a particular element, let's say I am currently at 0th index and I am checking for an element if its copy is present or not. then can I check for it at the same index from where I have taken? If I have taken 4 from the 0th index, can I check at the same index? No, I cannot, because if its copy is present in the array, it is going to be present at different index. For example, if I talk about 1, its copy is present at 3rd index. If 2 is there, its copy is present at 4th index. I cannot say that its copy is present at the same index. That's completely invalid, because that is going to be matched if I am going to check at same index. That is not valid at all. So this is the important note which we have to keep in mind, that if I am checking for index I, let's say, let's generalize it. If I am checking for the index I, then I cannot compare to the same index. Okay, I cannot compare to the same index just to check if it is present or not. Or I can also say like I can't. Yes, that's valid in itself, that if I am checking for the index I, let's say for the index 0, then I cannot compare to the same index. So now I will be taking the j variable in order to check if its copy is present or not. So here we can see that the index is same, so we cannot check here. We have to go to next index. Now the index is same. Is the index same here? No, index is not same. 0 and 1 are different. Then I will go to check the element. Now is this 4 equal to this element? No, it is not equal. It means it is not, the copy is not, this is not the copy. Move ahead. Is the same index? No, this is not the same index. Then check the element. Is the same element? No, it is not the same element. Then move ahead. Is this the same index? No. Is the different, is the element 4, is this the 4? No, it is not 4. Then move j ahead. Is this the same index? No, it is not the same index. It is different one. So I can check the element here. Is this the 4? No, it is not a 4. Then move ahead and the here loop will be ended. Now see, one important thing is that what we will have to do whenever we are going to check for a particular index, we will have to set a particular flag for it. Let's say I have at the start I have set a flag to true. Now what I will do is, whenever I am going at 0th index and before going to check its copy in the entire array, initially I will be setting its flag as true, and if I have found a particular match for that element, then I will be setting this flag as false, so that I can make a kind of validation that yes, this element's copy is present, so that I can check later on that what the flag value is, so that I can decide what I have to return and what not. Okay, so as of now, if this flag, if this for this element I am checking that this flag is true as of now. Now I am checking at this, so j is here now. Now index is same, so I will move ahead. Is the element matching? No. 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 So if the element is not matching, then I'm not going to make it as a flag as false. And at the end, when I will check that what the value of flag is, it is going to be true. And from that, I will come to know that if the flag is still true, it is not made as false. It means it is not matched with any of the element in the array while traversing. So this is the element which I am going to return. So that nums of I, whatever the value is, that nums of I will be my return value. So this is the whole approach. Now I think this is somewhat became easier because 4 is present, because 4 is the number which is a single number, and it's present at the first index itself. So let me take this example and the same example, and let me make it more, let me just modify it to have more understanding. Let me put this 2 here and let me put this 4 here. Now let's understand it more again. So what I will do again here is that I am firstly starting with the 0th index, and I am going to make this flag as true here. Okay. Now currently I am at first index. J will be starting to check here. Now is this the same index? Yes, this is the same index. So don't check here. I will move. This J will move ahead. This is the different index. Okay. Now this is a 2. No, it is not a 2. Is this a 2? No, it is not a 2. Is this a 2? It is no, it is not a 2. Is this a 2? Yes, this is a 2. So in this case, now what we will do is we will make this false. We will make this flag as false. And then and there, as I have found that this element is matched, I do not need to check in the entire array because I have found its copy. Its twice, its second element is present. I have found that. So no need to go in the array ahead. Just make this particular flag as false and break from there. Now what I will do, I will put a particular condition after this loop is getting ended, the second loop, and I will put a condition there that if this flag equal to true. Okay, so if this particular flag is equal to true, then what will be the case in that? It means I came to know that I have initially set the flag for this value as true when I was checking, I was going to check its copy, but still it is true. It means it has not been made as false. And if it has not been made as false, it means its copy is not present in the array. So I will just return this nums of I from here. This we will understand more when we are writing the code for this. Okay, so this is the whole approach. Now, as we have done for this 0th index, now move this I to the another index and start checking from the 0th index itself, because there might be the case that whatever the element I am going to check, its copy is present before this I index. I will start from 0 index again. Is this the same index now? No, it is not the same index. I will move ahead. Okay, so is this the 1? No, it is not a 1. Then move ahead. Is this the same index? Yes. So I will not check the element. Now move ahead. Is this a different index? Yes. Is this a 1? No, it is not a 1. Then move ahead. Now is this a different index? Yes, and it is a 1. If it is a 1, then whatever the flag value you have set for it as true, make it as false. And if it is false, again you will come here. Now this is false. It means you are not, that particular element is having the copy, so you will not do anything. You will just go to the different index, just like this. So this is the whole approach which will work. Okay, so now you will again check this for this particular, and starting from the 0th index itself, you will see that this is not a same index, it is a different index. So you will check for element, it is not a 4, and you will move ahead, it is not a 4, you will move ahead, the index is same, so you will not check. You will move ahead, yes, this is a different index, but element is not 4. Again, different index, element is not 4. And when this loop gets ended, you will come to this particular condition and you will see the flag you have set for 4 is true, and it is still true. It means it is not present. So you will just return this nums of I. Now let's get to the code editor and code it to have more clarity on this. So let's come here and firstly set the size of this nums inside this n. So I have taken the size of this. Now what I will do, I will just write a loop for indexes, just to go for different indexes. I equal to 0 to I less than n, I plus plus. And now what I will do, I will, for every particular index, for I equal to 0, I will traverse for the entire array. So in that case, I will use this j here, j equal to 0, j less than n, j plus plus, j plus plus. Now in this, what we will do, see, now I am currently at 0th index. Okay. Then what I will do, I will start checking from the 0th index till the end. And in this case, I will keep a check if this nums of I, for what I am checking the copy, for which I am checking the copy, if this nums of I is equal to this nums of j, then I will have to keep a validation that yes, I have found this element as a copy of the element for which I am checking. So I will have to set something. So as I have told that I will keep a flag here. I will keep a flag here which I will set for every element before starting to check its copy. So initially I will set it as true, and the moment I found that it is present in the array as a duplicate, I will set that flag false. And because I have found that particular element that its copy is present, so I no need to check it again in the array, in the array ahead, because I have found that its copy is present. So I will just break from here. I need to check ahead of the head of the array. So this is the simple thing we have to do. And after coming out of this loop, I have to keep a check for this flag, that I will check that what is the value of this flag right now. Flag is still true, for which I have already set for an element. If it is still true, then that's the element which is present only once, whose copy is not present in the array. So I will just return this nums of I here. Okay, And just to satisfy the compiler, I will have to return here -1 so that it do not give any undefined behavior. Okay, one more thing we have missed here is that I have already told that for whichever index we are going to check the copy, that we have not to compare with the same index. So before checking for the element, that this element is in, for checking the copy in the for it's like whenever we are going for to checking for the new index, firstly we will have to check if it is different index or not from I. So if it is I less than equal to j or not, if it is, then only check for the element. Okay, this is the whole code for this. Just run it. Okay, firstly I will have to take the size. So size I am having 5 in this case, and the elements are like 4. What are the elements? 4 1 2 2, 1 2 1 2. Let's run this. It is giving 4 as the number which is appearing once in this array. So that's totally correct. And now see the time complexity of this code. So time complexity is it is using the nested loops, for loops. So one for 0 to n for the indexes and one for 0 to n for the traversing to check the copies of the element. So for that the time complexity is big O of n square. It is clear from here. So we can see that the time complexity is n square. And we see the space complexity. So space complexity is going to be constant because not using any extra space. So this is the space time and space complexity for this approach. Okay, but the problem statement said that we have to solve this particular we have to have a solution which takes linear time and linear space, sorry, constant space. Okay, so but here we can see that the time complexity is big O of n square. That's not up to the up to the expectations of the problem which it has given in the problem statement mentioned there. So we will have to come up with a particular approach which can make us to solve a problem in linear time and also the constant space. Now one more approach is there, and it is not the better one, I can say, because it is a kind of brute force approach only, that it can just go just it can be just better than this particular approach. And that is the approach which is the help of sorting, I can say, and its code I have already written here. That using sorting, what we can do is, whatever the array we are having, this is the array we are having, and what we can do is we can just sort this particular array. So after sorting, how this array will look like: the one will come here, one will come here, two will come here, two will come here, and three will come here. So the sorted array will look something like this. And when we do sorting on this particular array, then we can start from this index 1 in order to check for its previous element. So when we, after sorting, when we check this element for its with its previous element, if it is equal or not. So if that particular element is not equal, it means that is the previous element is the element. This previous element will be the element which is present single only. That is, its copies is not present, because already we know that every element is present twice. So if I am starting from one index, then if it is not matching with the previous element, then obviously that previous element is present only single time. Its copy is not present, because if its copy is present, then then its copy must be present at the just next index, that is at I. So in this case, if we see, then this if the condition is matched, so this particular element is compared with this. So is this not equal? No, this is not the case. These elements are equal. So in that case, we need not to return the sums of I, and then I will move +2. It means it will be incremented to +2, because we are checking for the previous elements, and every element is present twice. That's why. So it will be checked with previous. Is this not equal? No, these are equals. So in that case, we will not return this element because it is present twice. Then I will move ahead 2 times. Now here the loop will get ended. Okay. Now the thing will come that this last element is the element in this case which is the single one. It means it is present only once. Because just take the another example. Let's say the example is 1 2, 2, 3. Okay, now if I am checking at starting from this index, from 0th index, it will check that previous element is it is equal or not. No, these are not equal. It means the previous element was the element which is whose copy is not present. If it were present, it was at the I, but it is not. It means that is the element which is present only once. So that is the element which I am going to return as nums of I minus 1. Otherwise, as in this case, we had already seen that if as this is the case, that every element is present twice, and we are completed with this whole particular traversal, then that was the second, that was the last element itself, which is present once. So in that case, if this entire process gets completed, then at the end we will just return nums dot back. It means whatever the last element of this nums array is, that we will return. So that is the last one. That is a single element present in the whole array. This is the whole approach, which is still now taking big O of n log n time complexity. Space is constant, but time complexity is big O of n log n, which is again not that efficient, because we have to go to the approach which takes the linear time and the complexity, space complexity as constant. So now we have till now we have seen the two approaches so far. So this is the solution 2, I can write here. Okay, this is the solution 2, the second approach. Now let's get to the another approach so that we can go with we can come up with the better time complexity. So now the solution 3. Now in this solution 3, what is going to happen? Okay, this is the solution 3. Okay, so in the solution 3, now what we can do is firstly let me take this array again. Okay, this was the array I am having, and now in this array what I can do is that I am having these particular elements, and every element is appearing twice, and one is element is appearing only once. So in this case, what I can do is I can store these particular elements in a particular data structure, in which I can come to know that what is the frequency of these elements coming, and at the end I will simply make a check on those particular elements, whatever the way in which whatever the way I will be storing in it. I will just check that which is the element whose frequency is only 1, and if it's the element whose frequency is 1, that is the element which I want as the output. So in this particular approach, I am going to use a data structure that is hash map, and in this what will happen is, just let me draw this so that it can store these particular values in the key value format. Okay, so firstly here comes the keys, and then here comes the value. It's a kind of, I can say, frequency. So the keys are like whatever the elements are there in the array, and value is like whatever the frequency of these elements will be. So as of now, if I am having this firstly I have inserted 4 here, and 4 will come here, and I will increment it. I will take its frequency as 1, because as of now I have found that it is present once only. Okay, then I will encounter 2 sorry 1, and 1 is present once as of now, and then 2 will come. Okay, 2 is coming. Now its frequency as of now is 1. Again 1 came, so I know that one already came. I will just increment its frequency to 2. Again 2 came, 2 is already present. I will increment its frequency to 2. Okay, so in the hash map now I am having this particular key value pairs in the format that this is the particular element, and this is written the frequency, that how many times it is present in the array. So simply I am going to traverse in this array using this I here, I variable, and just insert all these particular values inside the map along with their frequencies. Okay, and after doing this, what I will do, I will just go inside this map, to traverse inside this particular map, and check which is the particular pair whose frequency count is 1, and the pair which is having the frequency count, for the element which is having the frequency count as 1, that is the element which is present once in the array. This is the whole approach. Now just let's go to the code part and code it there. So firstly let me remove this code, and I'm already having the size of this nums inside n. Now what I'm going to do is I will just take this ordered map, and which will be having 2 parameters, one for the keys and second for the value, means one for the element and second for the frequency count, and this is the map name. Now in this I will just traverse in this whole array, int I equal to 0, I less than n, I plus plus, and I will take every element inside the map along with its frequency. So inside the map, I will take that nums of I. I will take that nums of I and just increment its frequency to 1, because as of now, whenever the element is coming, I will just increment its frequency to 1. So here 4 came, I make the frequency as 1, then 1 came, frequency as 1, 2 came, frequency as 1, and then 1 again came. So when I will implement this frequency to more 1, it will become 2. So that's how it is working. So I have taken all the elements now in the map. Now what I will do, I will use a range based for loop. So it is like auto, and whatever the pairs, see, and I am is going inside the map, so I will find the pairs. That pair, I will take every pair from that map, and then I will check that in this particular pair, I will keep a check here. If this pair from this map and whatever the second parameter is there in that pair, if that is equal to 1, it means pair dot second means the frequency count in that particular pair. So if it is equal to 1, then whatever the pair, whatever the first parameter is there for that pair, that I am going to return, because that is the element which came once. That's why its frequency count is 1 in the map. So that's the element in the array which is present once in the once. So here I will just return that pair dot first. This is the first parameter. Now one thing I can do here is I can use the reference here so that I cannot make the copy of those map elements. Okay, just to avoid making the unnecessary memory for the making the copy of that map elements, I can just take the reference so that I can directly reference to the map elements to take these pairs. And also, if we can think that whatever the values are there in the map elements, we may accidentally modify those values, may be modified if we are referencing that. So in that case, we can just make it as const, so that it is only readable. Those particular values are only readable, not writable. Okay. At the end, just to have this, just to prevent the undefined behavior, we will just return -1 in this case. Now let's run this particular code. So it should give the desired output. Okay, it is giving 4. Now let me take here the size as 7, and I will take the 4 duplicate and also 6 another. So it should give the 6 as a number which is appearing once in the array. Okay, this is the output. Now let's see the time complexity of this particular code. So talking about the time complexity, see, here the first loop is running for n time, just visiting every element once to count the and just to insert these elements along with their frequency count. So in that case, it will take n time, and plus this particular second loop is running for a particular how many times. See, if we see in this particular map, when we are inserting here, three unique values are stored along with their frequency counts. So here we can say that for a particular value k, we can say that the k unique values are stored in this particular map. Okay, so for a particular k, now we can also take the worst case, that what can be the worst case of this value of k. Worst case can be that all other elements in this particular array may be the unique elements, means any of the element is not appearing, that we can say that every of the element in this particular array is unique elements. So in that case, that this k value will be unique. It means whatever the size of array is, that will be the same value for k. It means all the elements will be coming in this map, and along with their frequency counts as 1. So in that case, the k value can go to n in worst case, and that's how this will become, this can go to big O of 2n, and average time complexity, we can say that yes, it is big O of n. But the space complexity, we now see here, space complexity is going to n, because we are using the extra space. It means the data structure which is nearly taking equal to, which may take, means in the worst case, as we already talked about, that in the worst case it may have the unique element, so it can have all the values, like the hash map we are using, just a data structure which is taking the space for all these values, the values present in this array. So here the space will be taken as big O of n. Now if we see this particular statement given in the problem, that it is saying we have to solve this particular problem with a solution which takes big O of n runtime complexity and the constant space. So as we seen in the above two approaches, in the first approach it took big O of n square time complexity and space complexity is constant. So here time was the problem. Now coming here, we have just some modified the time, but it is going to big O of n log n, but the space was still the constant. So here again only time was the problem. Now coming to this particular approach where we have solved this using the hash map data structure. So here we can see that the time is not the problem. We are simply solving it in big O of n time only. But the space, now it is taking big O of n. So here time is not the problem, here space is the problem. Now we will have to come up with some other approach which takes big O of n time and also the constant space. That it can be solved at linear time and also no any space is required. Again, let me take this particular array and now in this example, I can see that whatever the elements are present, here 4 is present, 1 is present, 2 is present, 1 is present, and 2 is present. Now I can, if I see clearly, then every element is present twice and 1 is the element is which is appearing once. So in this case, what I can do is that I know that XOR, how the XOR works. XOR works that whatever the elements are present twice, it will cancel out them, and whatever the element is remaining, it will just keep it as it is. So XOR operation works like this, that if the elements are same, let's say I am performing A XOR A, what will be the result? Result will be 0. It will cancel out. And if I am performing the XOR of A and with 0, A XOR 0, so the result will be the same element, that is A itself. Okay, so now if I can see that whatever the duplicates are present in this, or the numbers are present twice, 1 XOR 1 will get cancelled out, 2 XOR 2 will get cancelled out. It means 0 will be remaining of the result of these particular elements, of the elements which are present twice. And when 4 is remaining, when this 4 XOR 0 is performed, simple 4 will come. It means I will get the result, whatever the desired result I want. So the simple thing I have to do here is I will just perform XOR operation among all the elements in nums array. So if I am having this nums array 4 1 2 1 2, if I perform the XOR operation among all these, okay, so 4 XOR 1 here, then 1 XOR 2 here, here again XOR operation, here XOR operation. So what will happen? 1 will cancel out 1, 2 will cancel out 2, and in this case, what will be the result? The result will be that 4 XOR 0, and the result will be 4 in this case. Rather, if we see in the different way, that when 4 XOR 1 is happening, so the XOR operations perform operation perform like this. That what we write 4 in binary, it is like 1 2 4. Okay, so 1 0 0. This is the binary form of 4, and how we write 1 is 1 in binary, that is 0 0 1. Okay, so when the XOR operation will be performed, this 1 0 will become 1, 0 0 will become 0, and 1 0 will again become 1. So here the XOR of this will become 5. Then this 5 XOR 2 will be happening, and whatever the result is, its XOR will happen with 1, its XOR will be performed with 2. So likewise the XOR of this particular result will come as 4. But it's simple that if we see in the broader version, in the broader manner, that when this 1 XOR 1 is performed, cancelled out, 2 XOR 2 is performed, cancelled out, then only 4 is remaining. That's what the result we need. So just let's code it in the editor. So firstly, take the size of this nums. So this nums dot size is stored inside the n, and then just initialize this XOR 1 with 0 as of now, and then start performing the XOR operation for all the elements. Int I equal to 0, I less than n, I plus plus. Now perform the XOR operation. So XOR 1 equal to XOR 1 equal to XOR 1 of with every element, this nums of I. So now the XOR operation is performed, and whenever this is completed, we will just return this XOR 1 itself, because it will be storing that element which is present once in the array. So okay, everything is fine. Just run this code. Okay, so it is accepted, and let me submit it. Okay, it is submitted. Now if we see the time complexity of this, so yes, simple. We are using this for loop itself for performing the XOR operation for all the elements, so visiting every element once to perform the XOR, and we have not used any extra space here. Okay, just use a single variable just to have this XOR one, to just to return that particular value. So that's constant only. So if we see the time complexity here, time complexity will come out to be, if we see the space complexity, so space complexity will come as constant, and which is the desired result what we needed. Okay, in the problem statement it has mentioned that we have to solve this particular problem in linear time and the constant space. Okay, so it is the linear time and the constant space. Okay, so that's what the problem all about. Thank you.